Thanks so much for the privilege to be able to talk to you all today. It's a little intimidating because many of you have been my mentors over the 15 years that I've been a network engineer, and then in recent days focused on network observability, and for the last year and a half, focused on the application of data analysis processes and workflows like machine learning models, for example, on network telemetry, quantitative and qualitative data, and then being able to mine information, insight, something valuable from that. But getting into the weeds of it, so thanks very much for having me. The title is Using Large Language Models in Network Operations. I won't be using the term AI very much because I am being laser focused on LLMs, and we'll talk about what that means. And the theme that I hope that you recognize over the course of my talk today is that the use cases, the methods that we use for mitigation, the decisions that we make about architecture and therefore get reliable, repeatable, valuable results, all rely on you and me, engineers, human beings. So large language models wasn't the invention of the warp drive and faster than light travel, or the ability to send data faster than light over a network, or anything like that. It's a way that you're going to see shortly over the course of my talk that we can augment you and me as engineers. I'd like to introduce you to two people. These are AI-generated images. However, it is eerie how accurate they are. Now, the guy on the left, Paul, is not quite that handsome in real life, but nevertheless, these are pretty accurate. Paul is a personal friend of mine. His kids and my kids have grown up together. He makes this chocolate Guinness cake thing that he makes when we all get together. It's delicious. He's a senior engineer at a national healthcare organization that, if I mentioned their name, you would know who they were. And he's the perpetual technologist skeptic, in that he has his workflows. He has his ability and skills that he's amassed over his 20-year career. He's got his team. And hearing hype, hearing about new tech, he's very skeptical about it. And so recently, he was given the directive by his leadership that in 2025, next year, as we're closing out 2024, he needs to use AI. So I'm at an event with him, and I'm talking to him, and I'm like, Paul, what do you mean? And he looks at me and goes, Phil, I have no idea. I don't know what that means. What does it mean that I have to use AI? That's such an ambiguous, nebulous term. Is there going to be a robot in our cubicle? Is it just a chatbot that we all have on our laptops? Is it going to cost my team money, or does it come out of somebody else's budget? And I already have my workflows. I don't need any more. I don't need this. This is the C-level that saw a marketing video and they want us to do this thing, right? Hank is a little different. Hank is someone who's not a personal friend, but I met recently when I was going to a specialty plumbing supply store. It's a chain of stores in the Northeast, and I'm outside of the Albany, New York area. So I go to see him because my order for some parts for my shower repair, they weren't in yet. And I'm like, hey, you got to help me out. Can you look this up, find out which warehouse it's in? And it's over half an hour that he's clicking away on the keyboard. He knows his stuff, but he can't find my parts. He gets a colleague to come over. She's on a different terminal, clicking away, can't find the parts. We get somebody on the phone who's like the database computer guy, can't find the parts. Eventually, we did find them. They were in the Rochester warehouse, but then they got shipped to Buffalo, and then somebody else bought them. That took about 35 minutes to figure out. While he's doing that, he's telling me about his camper. He can't wait to go on this epic road trip and all these things. But I say to him, hey, you know what? What if you had some sort of thing on your desktop where you could just chat into it, using regular English, and ask it, here's the guy's name, Phillip Gervasi, or a part number, whatever it is. And then it can go out under the hood, not a technologist, right? And behind the scenes, go query all sorts of databases and find that information, present it back to him in human-readable English. And he's like, do you know that would solve like the biggest bane of my existence? Like, I want to retire immediately because we lose business. We lose orders, we lose customers because of this problem. And so I want you to keep that in mind. Many of you, and I love you all, I'm a nerd, you're a nerd, but we're skeptical of technology. We want to know the use case, we want to know the value. Is this smoke and mirrors? Is it marketing hype? So what we are doing with large language models and network operations is specifically augmenting a human being, augmenting an engineer, trying to keep the lights on, right, in an operational context. We're making the work that engineers do easier, and I'm going to talk about the specific work that I'm talking about, faster, perhaps even gain more insight from the incredible diversity and volume of data that we have in our networks today. And last, we're democratizing information among job roles, skills, titles, teams, levels. And that means that even a level 1 NOC engineer or SOC engineer, if you're a security person, can do things with this data that would require significantly more time, resources, skill level, maybe a team of PhDs from MIT to figure out. The image on the left is one of the earliest, if not the earliest, digital calculator, right? We all have calculators or have used them over the years. If you remember the TI-82 from back when I was in high school. That does not take away your ability to do math. It actually requires that you know how to do math. But what does it do? It assists you to do math faster, and it is a tool that you use in some larger workflow of whatever you're trying to figure out. And in the same way, on the right, Lotus 123, precursor to Excel, right? We have spreadsheets that you can embed formulas and do things and do that same math and figuring stuff out at much greater scale and greater speed. Nevertheless, we still have accountants, don't we? So it does not replace accountants. It doesn't replace the need to understand math, even if it's at a basic level, but it's a tool to augment you, an accountant, or whoever else is using spreadsheets, right? So let's pause on that and actually look at what are large language models in the first place, okay? Notice I haven't used the term AI yet. Probably won't. Large language models are built on probabilistic mathematical models, which ultimately what they do is use a corpus of data, large language models use text, to then predict what the most likely next item in the sequence would be. And in our case, we're talking about the most likely next words or many words in a very long sequence. And so when you type something into ChatGPT and you see it produce line by line, but technically word by word very fast, that's what it's doing. So that means it presupposes that there is no inherent intelligence, insofar as we know what human intelligence is. There's no real human-like reasoning or true thinking ability. Now, I know that we're hearing terms like chain of thought and reasoning in the context of large language models. So there are some that might disagree, some experts that disagree, because there is, interestingly, there's emergent behavior that's not well understood that happens in the hidden layers of a neural network. So if you read up on that, we're not exactly sure what's going on. There is a mystery involved here. Now, large language models then are basically a language framework, a semantic framework. They're trained on a very large body of text, as Duan mentioned. We have large language models like GPT that is trained on the entire text of the internet up until fall of 2023. Other models are trained similarly, perhaps on smaller amounts of data, but ultimately a body of text. And what they do is they take that text and break it down into tokens and represent those words and characters into something called embeddings, which is a numerical value. So now the computer can do something with it, right? And we take those numerical values and we put them into a vector database of whatever type, high-dimensional vector database. And now the model can look at that and identify, and by the way, if you're looking at it like on a screen, it's just tables, right? And it can look at that and identify relationships among the words. We call that semantic proximity. So the classic example is the king and man, queen and woman. They kind of exist close to each other in 3D or 7D space. So they must go together. Do you see how there's not a true understanding there, though? And so that is also one of the mechanisms that's used to then predict what the next words should be to your prompt. So as an example, we have these words, can you please come? The model has been trained on so many words and so many texts like Shakespeare and Juniper documentation, Ethan Banks' blog, my blog maybe, and produces the word here because it understands language. But it doesn't have that full understanding of context that you and I have. Now, I love Star Trek. I am a big Trekkie. This is a great episode, Darmok. What happens is Captain Picard and the whole crew of the Enterprise happen upon this alien race in outer space that, and they interface with them. And they're right there on the bridge, and they have universal translators, so it translates this alien race's words into English, presumably English. And so Captain Picard and Commander Riker, they're all there, and they hear the words. They understand the words. But the interesting thing about this alien race is that they speak using metaphors. And the metaphors are built on the context of that culture, of that alien race's culture, their mythology, their history. Captain Picard does not have that context. So though he hears the words, he doesn't know the meaning. Another example, to bring it close to home, is a very, very clever joke that somebody who I think was very clever put into the Autocon 2 Slack just about an hour ago. And they told the joke about how can you make a router laugh? Well, you tickle it in the rib. Okay, what does that mean? My wife is in the room. She doesn't know what that means because she's not a network engineer, right? But many of you that are know what tickle is. It's TCL, we're talking about tickle scripts, and a rib, a routing information base. Oh, and therein lies the humor. You laugh because you understand the greater context. This is a problem with large language models. One of the ways that we solve that is by using the transformer model. So transformers are still technically probabilistic in the sense that they predict based on the body of text, but they're much more sophisticated than that. There's an entire process of capturing long-range dependencies by processing a sequence at the same time, the process of encoding and decoding and all of that, along with something called an attention mechanism, which I believe Duan mentioned in the previous presentation, where we assign weights to individual words and parameters, and so now the model can identify what's more important and less important. I'm saying that it now understands context, but I'm using air quotes because that's still not quite context, but we're getting there. And in 2016, 2017, and then the subsequent years, that's why we are where we are with large language models today. But it does pose some problems still. As awesome as it is, as sophisticated as large language models are, especially the foundational models that we're impressed with, they do have some problems. Now let's bring it home for us in network operations. Number one, hallucinations, right? Hallucinations, if you're not familiar with the term, means the response or the output of the large language model that is factually incorrect. It may be grammatically correct, the correct syntax, it's confident, it sounds good, but it's just factually wrong. Large language models are not optimized to deal with real-time telemetry data, which is important for what we do. They're not necessarily adept at handling very diverse telemetry types or data types. So if you can imagine, you have VPC flow logs and NSG flow logs, and you're ingesting NetFlow and streaming telemetry, and you have your configuration files and your ticketing system, and all of these different types of data that you use to do your job and make the application work well. We have privacy, we have regulatory concerns, and it's yet another thing to learn. I was at Autocon 0, and the big question was, why aren't we where we thought we would be with network automation? It was largely culture. And here I am throwing this out at you, saying it's yet another thing to learn when we're still trying to get up to speed on network automation. So these are all challenges that we face in network operations for sure. And the solutions to all of those are ultimately going to rely on you and me, on keeping a human in the loop, involved with oversight, involved with the training, involved with the architecture, and in that way we can mitigate hallucinations, not solve hallucinations, by the way, but we can mitigate them. We can handle real-time telemetry. We can handle very diverse telemetry. We can do things like sentiment analysis, all that kind of stuff based on our involvement with the process. So let's pause, or at least stop with the large language model deep dive, and I want to talk about actual use cases. These are use cases that I use. They're not pie in the sky made up hypothetical, but that I use, and I'll show you some screenshots. First, large language models can help anyone, I pause there, anyone, query large, diverse, and even real-time data sets very quickly and easily. But before you cry foul and say, Phil, you just said that large language models can't do that with real-time data. Large language models can be an interface between you and a very sophisticated workflow that can do those things very efficiently, a lot faster than a level 1 NOC engineer might be able to do. Therein lies the making it available for everyone, democratizing information, reducing mean time to resolution, all those kind of things. So as a scenario, let's say you're a network engineer working on a forensics analysis. So you need to identify, I got an application that is sending out traffic, it's egressing a specific VPC from AWS over the last 24 hours, the last day. I want to know if any of that traffic was destined for embargoed countries. This is important. We have a security audit or whatever kind of a problem, right? It's mission critical. Now, keep that scenario in mind. Another use case is for programmatic data analysis. Notice that I use the word facilitate. Large language models in and of themselves can't do very sophisticated data analysis. They're trained in a sophisticated data analysis workflow, but they can't in and of themselves do that. They are language frameworks, which is awesome, by the way. But that's why when you ask ChatGPT about like history or something, it's been trained on the data of the internet. It read all the Cisco documents, so it feels like it knows everything about networking. It does not. It does not know anything about your network, so we have some problems. But it can be a very powerful interface, natural language interface, that greatly reduces the barrier of entry to a much more sophisticated workflow. Here's a scenario. You're troubleshooting a slow application hosted in Azure. The application is slow for folks only in Chicago branch and only at certain times of the day, every day. And we need to figure this out. What does slow mean? Now, I'm not going to say show of hands, but in my brain, it's like, all right, we're dropping packets, latency. I want to know about latency. What's the round trip time look like between this and this? Is it the service provider? What's going on? So there's a lot of different things that slow means, context. What is unusual or different or weird about the application or the network? This is sort of hinting at seasonality. This is a little bit more of an advanced data analysis workflow. Maybe I want to apply a SARIMA model or some sort of linear regression to do some sort of basic prediction. Large language model is not going to be able to do that. Let's pause with that one and talk about our third use case. Automated network operations workflows, which is basically what I talked about already with being able to access a more sophisticated workflow, but in this case, it's the idea, as Duan said in the last presentation, of a large language model facilitating you as the interface between you and AI agents and function calling and tool calling and doing all those things that large language models actually can't do. Now, I have been around long enough to have seen many network orchestration and SDN platforms come and go, all with the promise of the self-driving network and autonomous remediation, all of these things. Nevertheless, in spite of all those things coming and going, I am hopeful. I mean, we've been taking steps with network automation and abstractions and all of these things that I do believe that 2025 will be the year of the AI agent, and we can see some very, very impactful, meaningful applications of the technology to network operations. So what is the benefit? I think a lot of it was self-explanatory. We're going to reduce manual clue chaining. And if you're not familiar with that term, the idea of I see a clue of what the problem could be, and then you chase that clue, and it sort of points to another one. So you do that, and you do it again. And you are doing this very long-term, laborious root cause analysis. But it works. We do it. Our networks are running, generally. I do it. You do it. But I believe that the application of LLMs and network operations can reduce that, make that easier, thereby reducing your mean time to innocence, mean time to insight, lowering your mean time to resolution. When used in the context of a workflow of some kind of data analysis workflow, you have the potential to gain tremendously more insight from the data than your typical stare and compare at graphs and looking at metrics from various devices, but then being able to, using natural language, say what is the repercussion of changing this BGP peer from this to this, and what could happen to DNS resolution time. And therefore, a more autonomous network operations workflow. So let's get very specific now. How can large language models actually help us, as in like you could start tomorrow? Maybe not tomorrow, but like after the weekend in network operations. Here's an example for you. One easy way to get started, okay? Now, you're probably using it to help you generate code. So that's obviously a simple use case that's very effective. Great. One easy way to get started is to just drop your information into the prompt. Add data and context to your prompt. Now, this is not necessarily ideal, but it is an easy way to use LLMs right now. The context window for some of the models are very large today. GPT is 128,000 tokens. Claude is, what is it, 200,000? I'm not sure, but they're big, hundreds of thousands and more tokens. Now, I will say that there is a diminishing returns, that if you drop an entire, huge amount, and you use up that 200,000 tokens of flow logs, for example, into the prompt, there are things that manifest like lost in the middle, which is a problem where it does start to hallucinate because it can't keep track. But in this example, I gave it just a bunch of authentication logs, right? And I just asked it, this is Claude, analyze these logs and tell me how many authentication failures there are. This is a very straightforward, simple thing that you can do right now. And, are you uploading it to somebody else's model? Yeah, so there are some security ramifications. Can you run a small local model and do that? Yeah, and we'll talk about that shortly. So a simple way to get started is just dump your data into the prompt and use that to help you figure out your problems faster. Maybe it's text-based, but remember that the large language model can't really do serious math, so we're putting logs, we're doing that kind of thing. So another thing that you can do, again, something that I do, you can use the large language model to generate your queries for you. Now, this is a type of RAG, but without the vector database. But basically what you're doing is you put your prompt in, perhaps it's a query, and the large language model says, all right, let's take that and translate it to a pandas operation or a SQL query. And in your workflow, and that's an important consideration there, your large language model is not doing all the work for you. You do have a workflow, and the large language model is the interface for that. I'm just putting in like, show me whatever, show me this bandwidth utilization on these interfaces over this amount of days, right? Translate it to a SQL query because it's a time series, whatever, executes that against a SQL database, and you can even add to your instructions. Give it back to me in JSON so I can do a very pretty graph, or give it back to me in human readable format, and the LLM synthesizes it, puts it on your screen. You can do that right now. I say it's a type of RAG because what I'm doing is I'm limiting the LLM to the context of my network, okay? And I'm not sending that information out, like dumping the logs in the chat window, right? I'm not sending that out to the cloud to do. I am limiting it and just using the large language model to understand the language, give me back the code, whether it be a SQL query, pandas operation, whatever, and then apply it to the database. So here's an example. This is the first use case that I gave you. Show me all the application traffic egressing AWS US East 1 for the last 24 hours, destined for embargoed countries. You can see on the left, the LLM understands that, translates it to a SQL query, runs it against the SQL database or whatever database, and I get back JSON, as you can see on the right. And then in my workflow, I take that and I create a very straightforward graph. This could also be very simple human readable text as well. And these two screenshots are from my company, Kentix platform. Another thing you could do is use a RAG system, which has been mentioned several times today. Retrieval augmented generation is a method to, again, limit the responses of the large language model to only what you say or what you allow the LLM to look at. So what happens is you put your prompt into your chat, whatever, and those are tokenized and put into a vector database. They're created, you create embeddings and put them into the vector DB. That is added as context to your prompt so that when the large language model then, which is told to point at a specific database, has that context and can produce a enriched response. And so you can ask it about information regarding your specific network, your specific flow logs, whatever it happens to be, and thereby making your large language model very relevant. But there are still possible hallucinations there as well. Because remember, we're talking about semantic proximity. And there are times when a vector DB choice, am I using Chroma or Pinecone or this or that, can introduce additional latency or can introduce not as accurate semantic proximity calculation. And so that way you still get a hallucination even with a RAG system. So it's something that you have to be very involved in and measuring until it's fit for service. As a quick example, the difference between the word mouse and mouse. So the difference between like a computer mouse and then the animal mouse. So there are some considerations there. Here's an example. I can barely read it off this screen, so I might have to hunch down. So you're going to use an LLM with a RAG system using a vector database. Thank you. So your prompt could be something along the lines of, were there any unusual spikes in network traffic in the last 48 hours? You can convert those to embeddings. I have words that I can add as context. The retrieval mechanism then goes out to whatever database we're using, where you have already indexed all of that data, right? And now you get a synthesized, enriched response. Yes, there was a significant spike in network traffic on these days. And in that entire workflow, you're going to give your workflow or the LLM instructions. Don't answer questions if the data is not in the database. Who was the first president of the United States? It wouldn't answer it. I'm sorry, I can't answer that question. So you can put those guardrails in there and limit your query to just your data, thereby addressing to an extent one of those security concerns. Another option for making large language models relevant to you, and that you can do today, is fine-tune a model for your specific domain, networking, and your specific needs. Now, the likelihood is that you're not going to fine-tune GPT or Claude, but you can certainly download a model like Llama or Mistral, something like that, and there are different iterations of those where they might just be several 100 million or a few billion parameters, which is something that you can do locally on your laptop, though doing something like that might take a few hours, 10 hours, but you can feasibly train a model at home. But keep in mind that all of these processes require an incredible amount of data pre-processing, understanding what data is important to me, which vector database do I use, and all of that. But the actual code to fine-tune a model is not that difficult, and there are low-code options that can help you do it very quickly. But this doesn't solve the problem of real-time telemetry. What am I supposed to do? Fine-tune my model every 1 minute because I have like streaming telemetry coming in for my switches? So this is not an end-all solution. But I want you to think about fine-tuning as kind of like a closed book test. And what I mean by that is you have the model that knows the language. That was already built, right? It's Claude. Or Llama. Let's say Llama because you're going to do it on your laptop. Then it doesn't know anything about your network. So you give it the textbook, meaning your network data, and it studies it. And then it's done. You're done fine-tuning. And then later on, you prompt it, it studied for the test, and it can answer your question more accurately. RAG is not like that. RAG is an open book test. It never saw that data. You're pointing it at the database at the time of your prompt. So what I want to do is show you an example of something that I read just recently, over the summer, June, this paper came out, of RAFT, Retrieval Augmented Fine-Tuning. And it's a combination of doing both fine-tuning in a RAG system, and so it's like a closed book test an open book test that you also studied for, thereby increasing the reliability of the results and the accuracy of the results even more. The benchmarks are very, very promising for RAFT implementations. And these are all things that you can do this weekend if you wanted to. And last but not least, alluding again to Duan's presentation about agents, using AI agents with the large language model as your interface, not as the orchestrator necessarily, that's going to be the agent, but the agent uses the large language model to understand what in the world you're asking for, translate that, and then kick off the workflow to go do that thing. And they can be very, very sophisticated. Here is a very simple example, but you can have multiple large language models involved. You can have multiple agents doing different things. And on the bottom, you have various functions that you can call. This is a very small number. And the response or result could be a data analysis process, or it could be something much more sophisticated where there are decision-making processes along the way through a series of multiple agents where you end up pushing config. And this is why I do see the potential of the long-term ability to have a more autonomous network, that ideal, that dream that we've always had. I remember when every blog post and podcast about SDN and then intent-based networking, and then it disappeared. Where are those blog posts? And could this be it? I do wonder that. So how can you get started? As in, like, how can you get started right now? Now, before I tell you to download anything, I have been at this conference all week as well, and I know the situation with the internet. So don't start downloading this right now. Do it like later, your hotel room this weekend. But how can you get started right now? First, download Ollama. If you're not familiar with Ollama, Ollama is a framework application, whatever you want to call it. But basically, you can run your models locally. I use Ollama, and then I go to the, why does it say 111? The formatting went off. Nevertheless, point 2, go to huggingface.co and then download a smaller model of your choice, whatever suits your fancy, right? You could choose Llama 3.2, Mistral, something that you can run locally. Now, you're not downloading the model, of course, you're downloading the compiled code, but you can run it on your laptop in your hotel room tonight in Llama. Now you have an interface to start chatting right there. It's very CLI based, I get it. I personally like doing it and piecing it together like this so I can learn and understand, but certainly there are low code options as well. Third, go get a vector database of some type. There are cloud versions that are free. You can use something locally, whatever it happens to be, but do that and then put some data in it, run the indexer that does it for you. Don't worry about like figuring out chunk size and which embedding model. Just use whatever is built in and then start experimenting. Like Duan said, start simple, start easy, just get something working. Then use a programmatic workflow, because I've been talking about workflows, and the large language model's role in network operations isn't the large language model itself per se, but it's interface between you and something very sophisticated that you don't have to know how to use, or you don't know SQL, you don't know Python. Doesn't matter. The large language model does it for you and then kicks off the workflow. So use something like LangChain. There's others as well, but LangChain is very popular, to tie the pieces together in a pretty Pythonic bow. To create your web app, you can use something like Streamlit. These are just suggestions. Google it. There are many other things that you can use. And then there are low-code options like LM Studio, really cool. There's Amazon Bedrock we heard about. There's Azure AI Studio, and there's others as well. And you click, and you can create something very quickly. But it does presuppose that you have a handle on all of your data ahead of time, all your processing and what data you're interested in. Now, I'd be remiss if I didn't say this. As the great network philosopher, and dare I say poet, Jeremy Schulman once said, you can either build it, you can borrow, wait, let me start over. You can either build it, you can borrow, or you can buy. I'm sorry, Jeremy, if I messed that up. So I do believe that it's very important for us as technologists, even if it's for an educational purpose, to mess around with this stuff. Go download this stuff this weekend. Some of you are downloading it right now. Stop. You're killing the Wi-Fi. But it's important for us to understand how this works so we understand the use cases. We can have those intelligent conversations with the VPs and the C-level when they say, we're doing AI. And you're like, Paul, and you're like, well, why? And you can have that intelligent conversation. Or perhaps you're going toward the buy side because you realize that, my goodness, this workflow is incredibly complex and sophisticated, and I don't have the staff, time, and resources. That's very fair. And now you can have that same intelligent conversation with some of the companies like my own and others that are here that are starting to do this stuff as a packaged service. It's very interesting, but you need to be prepared. So I do encourage you, in any case, to go through the process, understand the technology, understand the moving parts, even if it's just with small data sets, making it work, doing something useful, and then, yeah, being ready to go. So, in conclusion, I'm assuming many of you started off 45 minutes ago or so as a Paul, the consummate engineer skeptic, rolling your eyes at more AI hype. I heard the word chatbot, I saw the word chatbot used in the NAV Slack this week quite a bit. But I'm hoping that over this past 40 minutes or so, you are now more of a Hank, understanding the actual practical use case and how it can help you right now in your day job keeping the lights on. Thanks, Todd.
I checked your slides, Phil. It's not me. Thanks. That was good, and I did transition very slightly from the engineer to the plumber. Not all the way though. Question: given the potential for hallucinations, do you have any advice on how we should think about use cases where we might need a precise answer versus an estimate, where an estimate is maybe not good enough? Right. Or maybe do we just avoid the use cases where we need precision for now? Mm-hmm. What are your thoughts on that?
There's a couple of different ways to look at that. So first of all, if you're using a RAG system, which is really what everybody's doing right now, and you're using certain vector databases, make sure that you truly understand the quality of the results that you're getting back from one vector DB versus another, because you're going to see a difference. So that's one thing to do. Or avoid using vector databases altogether and just query the metrics. And you're going to use the SQL query or the pandas operation. You're going to get the metrics back, and the LLM is just translating it for you. And in your workflow, you can make a graph in whatever system that you're using.
Got it. So just make it a runner, not an interpreter.
Yeah. And that's really my goal here is how do you get started? What are the use cases today? Sure, agents are awesome, and I'm looking forward to that. But what can you do this weekend or next week?
You gotta reach for it to give me the mic. All right, Phil, thank you. Great talk. Do you want to clarify maybe about, when you say go and dump data into a random LLM, maybe, possible, don't put sensitive information or possible GDPR violating things, or maybe, don't get sued. I come from the civilized world where we have data protection laws, but I know we're in America and we can do whatever. But we know that the data is being trained on, so maybe go a little bit on that.
Oh, absolutely.
Some hygiene stuff.
Sure. So number one, if you don't want your data going to GPT, so if you have an enterprise account with some of the foundational models, there's going to be some protection that's a legal wrapper. And so your data is not going to be shared or trained unnecessarily. But you can also obfuscate that data. There are methods that people are doing that are common methods that have been using, like in transmitting credit card information for years and years, that are now being used to transmit your prompt. But you want that, what you're doing then is getting that prompt back, and then you're applying it now that you have it, right? You're getting that information back and using it on your workflow in the back end. So the real concern there is sending that prompt back and forth. So it's something simple things, instead of saying like Anne's PII or her information about credit card information, call it user one. So there are simple things that you can do to scrub data on the way out. Another thing that you can do, which many people are doing, is just run a local model. You can, and if it's not necessary to spend $25 million on all of this equipment to do that. You can run a relatively small model. And what's interesting about small models right now is that instead of using a general purpose model like GPT, which is an awesome model, by the way, it does a great job. That's why the benchmarks are very high for it. Why not just run a very small model, lower resources, cheaper, train it on your data, use a RAG system. You're not asking it about the history of Denmark or about internal combustion engines. You just need that ability to parse language and then have very specific domain that you're interrogating. So you don't actually need a huge foundational model like GPT or Claude.
Hi. Great talk, by the way. Do you see LLMs being more useful for experienced engineers to make them more productive, or for less experienced engineers to make them to allow them to do things they wouldn't otherwise know how to do?
Yeah. Well, I said both in my talk, right? I did. I believe that the democratization of information, or at least of the ability to kick off workflows, is very important. And you can picture in your imagination a level 1 NOC or SOC engineer being able to say, I don't know anything about Cisco syntax, or I didn't even think about checking like packet count or drop packets or CRC. I didn't even occur to me. But they can ask in natural language, and you can start to develop those queries as a result. So yes, do I think it's going to help inexperienced or new engineers? Yes. What about very experienced engineers? Well, yes, because I don't feel like figuring all that out, and I got to write the code to do that, or and so it's difficult for me to answer one way or the other. I don't think I can, but the answer is yes to both.
Thanks.
I want to come back to the smaller models. What is your take on techniques like LoRa? On how do they combine with the Raft?
It's interesting, isn't it? So you said LoRa, right? Low-rank adaptation. We're talking about finding a way to when we fine-tune a model, what we're doing is we're training it on this new data. There are different ways to do it, but we're modifying the parameters in order to get the results that we want based on our training data, right? And there's different ways to do it, but LoRa found a way to do that efficiently, where we're only modifying a smaller subset of parameters that still produces a result that is within the limits of accuracy. And so when you ask, what do I think about it? I think that's great because it makes the ability to train small models more accessible and less resource intensive. But it is in the context of a greater workflow. I don't think it's like, figure out which model to use. I'm going to use that one because that's my favorite. That's got the #1 hit on like Hugging Face boards right now. That's what everybody on the leaderboards is using. You do have to marry that to which vector database, which embeddings model, your own data processing. Have you done the proper data cleaning and imputation and interpolation on your missing values and things like that? So to answer your question, I think that's great for making it more accessible.
Given that there are so many available models, are there things people should be thinking about when deciding what model to start playing with, or does it matter at this early stage?
Oh, if you're just going to start playing with it? I don't know if it matters if you're just messing around with stuff like you just downloaded a llama. Drew, I don't know if you just did that, but.
I did not. Don't blame me for the Wi-Fi.
Okay. But in that sense, no, I don't think it matters that much. But in a production sense, yes, I do.
So what are those kind of considerations then if you're moving to a more serious use case?
What is the accuracy? What is the latency to access it if you are using their API? Things like that. What is their security posture and their mechanisms that they're using as far as that's concerned? But accuracy is a big one. And so you're going to see marked differences with Claude and Llama and GPT based on your use case. So Kentic, for example, does prioritize GPT, but we give you options for other models as well that we can run based on your particular needs. But listen, for messing around with stuff, just download something small. Llama 3.2 is great. It's like a couple hundred megs, then you unzip.
Oh, where'd the other mic go? You have it, Chris? Cool. All right, Phil, thank you.